Hi, this is Professor Gaurang Patel from Mahatma Gandhi Institute of Technical Education and Research Center, Navsari, which is also known as Mgiter Engineering College. I am from Electrical Engineering Department, and today we will going to discuss about the subject digital control and its applications. So basically, what is digital control? These are the basic components of digital electronics that what we can see in the diagram. We can see at the center there is a computer over there. After that, there is a digital to analog conversion block we can see over here, which is convert the digital signal to the analog signal. This signal is fed to the control element, and further it will be go to the plant. Now we can see the very important part over here, that is the sensor. It is also known as the feedback unit as well. So basically what the sensor will do, it will sense the output of that plant and give those signals to the analog conversion device. So over here, once again this analog signal is converted into the digital signal, and this digital signal is fed to the computer. Well, why we required to convert the analog to digital signal, that we will discuss it later. But basically what happened when we use the computer, and the computer, that is, he only knows the language in the form of digital data. That's why we need to convert analog signal into the digital signal. So after the conversion of analog signal to the digital signal, computer use this information to do certain modification according to the requirements. Now further we will see some of the basics of what is digital control system, role of computers in digital control system. Okay, so basically what is digital control system? We can see that a control system is an interconnection of the components to provide a desired function. And here a digital control system uses digital hardware, usually in the form of a programmed digital computer. Well, digital computers were first applied to the industrial process control in the late 1950s. Over there, industrialists use those computer based application to control their plants. In their plants, they are controlling the temperature of the machine, pressure of the machine, flow of the machine, etc. But those parameters are controlled individually, or it by means of electronic or pneumatic controllers. So the main function of computer was to gather information on how the overall process was operating. So for that, computer needs the information in form of digital data or digital signal. So how those analog signal is converted into the digital signal by means of quantization. What we will see, we are focused over here, just a minute. We are focused over here to this particular area, that is analog to digital controller. Okay, so for conversion of analog signal into the digital signal, there is a process called quantization. And in this lecture, we will learn about how the quantization is made, what are the factors to be considered when we convert analog signal into the digital signal. Now here we will discuss the steps of quantization. There are mainly three steps of quantization through which we will do the process. So first we can see over here, just I will show you, mapping the continuous range of values into a finite set of values. The next one is changing the infinite precision to the finite precision. And third one, and most important one, that is the rounding the samples to nearest quantization level. So why we need this quantization? Once again we will just go backward, so where we can see over here in this diagram, because the sensor which sends the signal in the form of analog, and those analog signal we have to convert into the digital, because computer only understand the digital format or digital language. So analog signal by means the any kind of signal, we will see the some of the examples of analog signal, and then we will take one sinusoidal signal for the better understanding. So and for the analog signal we can consider which will be any one of them, like whatever the sensor given the signal in the form of, maybe it should be like that, it should be in like this step size, it should be like that, or it should be like that. So all those signal can be considered as in form of analog signal. So I hope you understand what is the analog signal is. Now we will discuss with taking one sinusoidal signal and do the calculation for the quantization. Over here, okay, now we will take one analog signal and take the samples from that analog signal. Okay, so how we will take the samples from that analog signal? It is just like that. We'll divide it, these analog signals, into the 6 equal steps. Okay, so those are the samples over here I have to take. Okay, after taking the samples we have to decide how much quantization level will be there. So there is a certain procedure to get the quantization level. Okay, so for that, first of all, what we have to do is we have to decide the number of bits. Over here, number of bits, that is n. Suppose there is a number of bit is 2. Okay, and then one more equation, that is the number of quantized levels. So that number of quantized level, that is L, is equal to 2 raised to n. Okay, over here we will just take, this is an example for understanding. We will see it in detail, but over here we just take this for the understanding. So what we take, the n, that is the bit depth, and L, that is the quantized level. The bit depth what we choose, n is equal to 2. So 2-bit data is there. Okay, there is a 2-bit data is there. Okay, then next I just show you, I just removed some of the unnecessary things. These are the two useful things for the next equation. Okay, now if we take the bit depth is 2, so from the equation of quantization level we will get over here 4. Okay, so quantized level, that is 4. I already drawn this quantized level. We can see we have to calculate it from, or consider it from the bottom. This is the first level, this is the second level, this is third, and this is the fourth level. We have to consider this 0 is also at, as an quantized consideration in quantized level. Okay, so before proceeding further, we also have to know the what is the step size. Okay, how the step size is decided. We can see the one level is at there and the next level is at the zero point 0.5. So, and then 0 and then at the zero point 0.5. So here over there is a zero point 0.5 is the step size, but how it will be achieved? So it will be achieved with the equation delta is equal to x max minus x min divided by L. Okay, x max minus x min divided by L. Over here x max we have to consider, this is the x max and this is the x min. Okay, so value of x max, that is 1, and value of x minimum, that is the -1. If these two value, if we put those values over here, so x max, that is 1 minus -1, and we also have the value of L, that is 4. So our answer is 0.5. Okay, so this is considered as the step size. Delta is equal to step size 0.5, and that's how these steps will be taken for the quantized level. Okay, now we will see in next slide. Okay, that's how exactly it's look like. Okay, you can see first we will take the bit depth. Okay, over here where n is equal to 2, then we will take number of quantized level. The equation for that is L is equal to 2 raised to n. So the answer of L we will get 4. Then we decide the step size, delta is equal to x max minus x min by L. So we got the step size at the 0.5. Okay, now we take the bit depth, n is equal to 2. So bit depth is what? That is 0 0 0 1 1 0 1 1. So for that 4 quantized level we will put these values of bit depth likewise that. Okay, I hope you understand how the step size and quantization level will be achieved. Next, we will take one example regarding the step size and quantization level so you can understand more in detail. Okay, now we will take just a quick look of the step size and quantization level. So first of all, we take one analog signal. Okay, then we will take the samples of that analog signals. Okay, then we decided the bit depth, that is n is equal to 2, so that's why 2-digit data is there. This is the 2-digit data 000110 and 11. Then next we decide the number of quantized level with the help of the equation L is equal to 2 raised to n. So number of quantized level L is equal to 4. So here is the number of quantized level, level number 1, 2, 3 and 4. And here then we find out the step size through this equation, and the step size we will get, that is zero point 0.5. Okay, so as we will get the number of quantized level L is equal to 4, so first level we have to start from the bottom, so it is started from the -1, then minus zero point 0.5 due to the step size of 0.5, then 0 and then zero point 0.5. I hope you understand this very well now. Okay.